Start the video. So here we are, summer 2013. Question 1. Actually, we did quite well on question 1. A and B are 2 points in a line of grid sloping from a smooth inclined plane with B a vertical distance of 8 metres below A. Dave drew a diagram when he did that. That is a straight line. Actually, it wasn't, so let's try again. That is a straight line. And I marked my two particles on here as being, oh, there we are, and there we are, and I recognise that that height there is 8 metres, because it says a vertical distance of 8 metres below the level of A is where B is. There we are, A and B. A particle of mass 0.75 kilograms is projected down the plane with a speed of 2 metres per second. Find the loss in potential energy of the particle as it moves from A to B. What all this is we remember gravitational potential energy is mgh. So that's mgh. So that is the mass times 9.8 multiplied by the vertical height that it's lost, which is 8 metres. We were given that in the question. 0.75 times 9.8 times 8 gives us 58.8. And they're not going to get too upset about this, but what is the unit that we measure this in?
Joules.
Joules. So that's part 1. Okay. The speed of the particle when it reaches B, well, here we've got to bring into account the change in kinetic energy. The change in kinetic energy is going to be equal to this loss in gravitational potential energy. So the change, well hang on, let's call that V. And so we've got that the increase that we've got here is going to be half mv squared. So this, we're losing that gravitational potential energy, where increase in kinetic energy is a half mv squared minus a half times m times 2 squared, 2 being the initial velocity, so that's a half times 0.75 v squared, strange use of brackets, minus a half, so that's 0.75 times 4, and that change is equal to 58.8, that's what we had in the first part. So 58.8, this works out as being quite a nice set of figures, isn't it? It's 3/8 of v squared minus 3/2. If we rearrange that, we get v squared equals something, but of course we know that in this context v is going to be a positive amount, isn't it? So we have v as being 12.7 meters per second. And there we go, that came from solving that equation. 4 marks. Your marks were for attempting a change in kinetic energy equation and then equating your change in kinetic energy to your potential energy from part 1 and solving it for the final mark. Okay? You could also have done equations of constant accelerated motion being v squared equals u squared plus 2as, taking the acceleration as g over sine theta, or g sine theta, sorry, that's what you got for that. Okay, so that would have worked as well. 6 marks. That's great, I'm going to stop the video in between each. So